Welcome back to Introduction to Software Reverse Engineering. In this module, we will talk about C Runtime library and the ways it can be used by the applications that need its functionality and how it affects the reverse engineering process. Let's dive in. Welcome to Module 9. In this module, we will explore the C Runtime library, a crucial component of applications built with C and C++. We'll dive into the importance of this library, the different ways it can be linked into executables, and how it impacts the complexity of the reverse engineering. The big question of today's module is static versus dynamic. What are the differences between static and dynamic linking of the C Runtime library? How does these linking methods affect the structure and complexity of executables? What implications do these differences have for reverse engineers like you? Let's get started. Remember that all the materials covered in this course are available on GitHub. These materials include the source code as well as the compiled binaries that are exactly the same binaries as reverse engineered and shown in the videos throughout the course. The C Runtime library, or CRT, provides the implementation of standard functions defined in the C language standards. These functions are required for program execution and include memory management functions like malloc and free, input-output functions like printf and scanf, string manipulation functions like string copy and string concatenation, and various mathematical operations such as sine, cosine, and square root. These are just a few examples of how many functions that make up the CRT. Understanding the CRT is essential not only for developing programs in C and C++, but also for reverse engineering the same programs. Static linking embeds library code into an executable file at compile time. This approach offers several benefits, including faster execution and improved security, since the executable contains all the necessary code. Key advantages of static linking: faster execution due to no dynamic linking overhead, easier deployment with a single executable file or fewer dependencies, improved security by reducing the risk of DLL hijacking. However, static linking also has some drawbacks: larger executable size due to embedded library code, increased memory usage when multiple instances of the same library are used. When to use static linking? Static linking is suitable for critical applications, embedded systems, and security-sensitive applications where performance, reliability, and security are top priority. Now, fire up Ghidra and import two new example programs, dynamic.exe and static.exe. These programs are extremely simple, but they show a big difference between the static and dynamic linking of the CRT into executables. In this module, we will review the programs that were compiled with Microsoft Visual Studio 2005. The reason for this is that it allows for user configuration of CRT linking, and it happens that I have it handy as well. The example program is quite simple. It uses function printf from the C standard library to print message in the console. In the project configuration of static.exe under C++ code generation, you can see Runtime library option. Multi-threaded value indicates that the CRT must be linked statically into the application. Now, let's see how static CRT linking affected the compiled program. The symbol tree window contains only one import library, the kernel32. The kernel32 library is a foundation DLL for most Windows applications that allow applications to interact with the operating system. Since the CRT was embedded into the application, and the program doesn't use other libraries besides kernel32, therefore, kernel32 is the only imported DLL into the application. Dynamic linking loads library code into the memory at runtime, reducing executable size and memory footprint. How it works: compiler generates object files, linker resolves symbols, dynamic linker loads library at runtime, program uses library functions. Advantages: smaller executable size, less memory usage through shared libraries, easier maintenance without compilation. Disadvantages of dynamic linking include slower execution due to dynamic linking overhead, dependency management complexity, security risks such as DLL hijacking. When to use dynamic linking? Dynamic linking suits most applications, large projects with shared libraries, and plugin architectures where modularity is key. Now, let's take a look at the source code of dynamic.exe example program. It is a very simple program as well. The configuration of the program project instructs Visual Studio to dynamically link with the C Runtime library, as indicated by the multi-threaded DLL option. Now, let's see what Ghidra tells us about the dynamic CRT linking. The symbol tree window shows that besides kernel32DLL, the program also imports MSVCR80 library. The MSVCR80 library stands for Microsoft Visual C Runtime 8.0. Different versions of Visual Studio contain different versions of the CRT library available and required for the programs to run. Compilation of the same example program with the modern version of Visual Studio will have dependencies on different CRT dynamically linked library. By double-clicking on printf function, Ghidra will navigate to the function import label in the listing window, instead of showing the function body as it is done with the static CRT linking. In our next module, we'll dive deeper into the world of arrays and code patterns in Ghidra's decompiler. We will explore advanced array examples, learn how to reconstruct the operations performed on arrays and their elements. All course materials are available on GitHub. Stay connected and see you in the next video. If you are looking to dive deeper into software reverse engineering, I'd like to recommend my book, Software Reverse Engineering: Navigating x86 Windows Applications with Ghidra. This course draws heavily from the book's content. However, the book itself contains many more examples and insights that can help developing your reverse engineering skills. The book is available in both print and digital Kindle versions on Amazon, making it easy to access and read wherever you are. Additionally, the book covers subjects not discussed in this course, such as reverse engineering of C++ programs, classes, virtual functions, and more. I encourage you to check it out. Thank you so much for watching and learning with me today. If you found this video helpful, please hit that like button and subscribe for more content like this. Your support means a lot to me. If you have any questions or topic you'd like to discuss, leave a comment below or shoot me an email. I'm happy to chat. If you'd like to support me and the channel financially, you can do so through Ko-fi or Patreon. Links are in the description below. Thanks again for watching, and I will see you in the next video.